Hey everyone, welcome back to the Incredible India podcast series. I'm Sam, and I'm joined by Taylor for a deep dive that is frankly going to completely upend how you think about the history of
That's
science.
absolutely. It's a total paradigm shift.
Right. I mean, think about it. If you used a smartphone this morning or sent a message with like end-to-end encryption or even just managed to survive a high school algebra
Which
class.
is a huge achievement in itself.
Yeah, exactly. But if you did any of that, you are actively relying on concepts that were invented hundreds of years before Europe supposedly, discovered them.
Right, and the fascinating thing is, these concepts didn't just bubble up randomly across the globe.
No, they didn't. They came from a single, intensely concentrated hub of innovation, which was the ancient state of Karnataka.
Yeah, Karnataka between, well, mostly the 7th and 12th centuries operated as this massive cultural incubator for genius.
Just a total powerhouse of ideas.
Exactly. And you had this really fertile collision of two forces there. On one hand, you had immense royal patronage, like kings from the Rashtrakuta dynasty just pouring resources into scholarship.
Right.
And then on the other hand, you had these rigorous Jain philosophical traditions. And they were, deeply obsessed with systematic logic. They wanted to classify the physical world, and they demanded rational explanations for how the universe actually operated.
Which makes total sense because if a culture is obsessed with classifying the universe, they are obviously going to need a very precise language to do it.
Yeah, exactly.
Which takes us to the absolute foundational building block of modern numbers. We have to travel back to the 7th century to look at a scholar named Bhaskara the First.
Right, so in 629 CE, Bhaskara writes this sprawling critique. It's called the Aryabhatiyabhasya.
Okay.
And nested right in the middle of these dense astronomical and mathematical arguments is a moment that forever altered human history. He became the very first person on record to write the Hindu-Arabic decimal zero as a circle.
I really want you to visualize that for a second. That little hollow circle. It is effectively the big bang of the digital age.
It really is.
I mean, every single piece of binary code, the endless chains of ones and zeros that are currently pulling this audio file from a server and beaming it into the device you're listening on right now, all of it relies entirely on that conceptual leap.
The idea that zero isn't just, an absence of something.
Yes, that it is a distinct, workable, operational number represented by a specific symbol.
And Bhaskara was using that symbol to do some incredibly heavy lifting, too. I mean, one of his standout achievements in this text was developing a highly accurate, rational approximation of the sine function.
Okay, wait, let's break that down for a second. Because for someone who hasn't thought about the sine function since high school trigonometry, what does a rational approximation actually mean for a mathematician operating in the 7th century?
So think about ancient astronomers, right? They're trying to map the night sky. They needed to measure angles and distances between celestial bodies. And the sine function gives you the ratio between the sides of a right triangle, which is crucial for those calculations.
Okay, makes sense.
But without modern calculators or advanced calculus, finding the exact sine of a specific angle is notoriously difficult. Ancient navigators and astronomers usually had to rely on these massive, really cumbersome lookup tables.
So it's like pages and pages of numbers.
Exactly. But what Bhaskara did was derive an elegant, compact algebraic formula that allowed you to calculate the sine of any angle up to 180 degrees.
Oh, wow. So basically any point across the entire visible dome of the sky.
Yes. And his formula was nearly flawless. It achieves an accuracy rate of over 99%.
So he essentially built a mathematical shortcut that let an astronomer calculate planetary positions by hand without losing any meaningful precision.
Right.
But, the aspect of his work that I actually find most fascinating isn't even the formula itself, it's his epistemological stance.
Oh, yeah, the demand for proof.
Right. He introduced this massive shift in how knowledge was validated.
He really did. He insisted on mathematical proof. Like, he famously took aim at the prevailing Jain tradition of the time, which broadly accepted the square root of 10 as the value of pi.
Right, which was just kind of the accepted standard.
Yeah, and Bhaskara, I looked at that and basically argued that you can't simply use a value just because it was handed down by earlier scholars. He demanded to see the geometric proof that demonstrated why it worked.
And I try to put myself in the shoes of a 7th century scholar here, because in a society that is deeply rooted in reverence for elders, where knowledge is largely treated as inherited authority, demanding proof feels like a radical, almost dangerous departure.
Oh, definitely.
Like if the sacred texts or the venerated masters say pi is the square root of 10, telling them they need to show their work sounds like it's bordering on insubordination.
It was a huge intellectual risk, because challenging inherited authority requires establishing a completely new foundation for truth. By demanding proof, Bhaskar Iyer was really laying the groundwork for the modern scientific method.
Wow.
He was asserting that truth isn't defined by who said it. It's defined by whether it can be independently verified through logic.
And that concept of verifiable truth became so integral to India's scientific identity that, skip forward a bit, in 1979, the Indian Space Research Organization, ISRO, actually named one of their early satellites after him.
Which is such a brilliant tribute.
It is. The poetic justice is just beautiful. The Bhaskar I satellite was up there orbiting the Earth, sending back telemetry data using the exact binary digital mathematics that his circle for zero made possible.
It's a perfect full circle moment, pun intended.
Oh, I see what you did there.
But, once you establish that mathematics requires rigorous independent proof, it inevitably outgrows its role as just a mere tool. By the time we move forward to the 9th century, mathematics is ready to declare its complete independence from other disciplines.
Right, and we see that independence declared really loudly around 850 CE by a scholar named Mahavira, or Mahaviracharya, and he authors a text called the Ganitasara Sangraha.
Which, amazingly, stands as the first known text in human history devoted entirely to mathematics.
Which is wild to think about.
Yeah, because prior to Mahavira, math was always embedded within something else. It was, a chapter in an astronomy treatise, or just a computational tool used in astrology to calculate horoscopes.
Right. It was a supporting actor.
Exactly. Mahavira formally divorces mathematics from the mystical and observational sciences. He establishes it as its own distinct, standalone field of study.
Okay, but I have to push back on the reality of doing that in a 9th century royal court, because divorcing math from the mystical sciences seems incredibly perilous.
In what way?
Well, astrology was essentially how kings made massive geopolitical decisions, right? When to go to war, when to plant crops. If Mahavira steps up and says, my numbers operate independently of your mystical prophecies, isn't he risking his funding, or worse, his status at the court?
Well, it absolutely would have been a massive political risk if he didn't have the backing of a spectacularly powerful patron.
Ah, okay.
Mahavira was protected and funded by the Rashtrakuta king Amoghavarsha. And this was a ruler who operated on a wildly ambitious scale. Amoghavarsha famously offered a piece of his own hand as a blood sacrifice to the goddess Lakshmi just to end a severe famine in his kingdom.
Oh, wow. That is the definition of having skin in the game, literally.
Literally. And to put the cultural weight of this dynasty in perspective, the Rashtrakutas were the same rulers who commissioned the monolithic Kailashnath temple at the Ellora caves.
Right, where they carved an entire massive temple complex out of a single piece of solid rock.
Exactly. This was a dynasty that didn't just support standard architecture or standard thinking. They funded audacious, monumental leaps in human capability. So Mahavira is writing his textbook in an ecosystem that actively rewards massive intellectual swings.
And the textbook he produces is massive itself. We are talking about over 1,130 versified rules. He's standardizing operations with fractions. He's outlining how to calculate quadratic equations, laying down the rules for negative numbers.
Yeah, it's incredibly comprehensive.
Even his linguistic impact is staggering. The specific terminology he coined for geometric shapes, like the words for rhombus, equilateral triangle, and isosceles triangle, those are the exact terms still being taught to students in Canada and Sanskrit classrooms today.
1,200 years of unbroken linguistic continuity.
It's unbelievable.
But beyond just standardizing what was already known, Mahavira possessed this rare ability to look at the boundaries of his own framework and perceive what was missing. He made the unprecedented claim that the square root of a negative number exists.
Which introduces the concept of imaginary numbers a full 7 centuries before European mathematicians formalized them.
Right.
And to understand why that is so mind-bending, you really just have to look at basic multiplication, like a positive times a positive is positive.
Right.
And a negative times a negative is also positive. So finding a number that multiplies by itself to create a negative result breaks the fundamental rules of arithmetic.
Yeah. Modern math eventually solved this by creating a whole new axis of numbers, which we call imaginary numbers. Now, Mahavira didn't have the algebraic language to fully map that new axis yet, but he possessed the mathematical intuition to realize that the paradox was real and that the universe contained mathematical realities outside their current framework.
It's kind of as if Mahavira is standing in this grand hallway of the mathematical universe, pointing to a locked door and telling everyone, hey, I know our current keys don't fit this lock, but the math proves there's a room behind this door.
That's a perfect way to put it. He validated its existence for future generations.
Right. Now, while Mahavira was writing these incredibly clear, comprehensive textbooks designed to basically democratize math for public understanding, another scholar in that exact same 9th century era was using pure math to do the precise opposite.
Yes, he was using numbers to hide information.
Exactly. This is where we encounter Kumudendu Muni. He's a Jain Digambara monk operating around 840 CE, and he creates a magnum opus known as the Sirabhuvalaya.
Which is just a structural marvel.
It is. It's this massive literary and scientific work written entirely in Kannada numerals, a script known as Anka Lipi. He doesn't use a single alphabet letter. Every phonetic sound, every word is encoded as a number.
And the sheer scale of this project almost defies comprehension. The Sirabhuvalaya contains 600,000 verses.
600,000. To give you a point of comparison, that is roughly 6 times the length of the ancient Indian epic, the Mahabharata. And it was all composed numerically. Like, how does a single human mind sitting in a 9th century monastery without any computational tools even conceptualize a 600,000 verse numerical grid?
Well, it requires an absolute mastery of matrix-based combinatorics. Kumudendu Muni didn't just write numbers in a line. He arranged the Kannada numerals into these vast interconnected grids, specifically 27 by 27 matrices, which he referred to as chakras.
Okay.
And to read the text, you couldn't just scan left to right. You had to navigate these grids using highly sophisticated substitution and transposition ciphers.
So just to break that down for the listener, a substitution cipher is like assigning the number 1 to the letter A and 2 to the letter B. But a transposition cipher means the grid itself is scrambled or requires a specific directional path to read it.
Precisely. So depending on the mathematical key you applied to the 27 by 27 chakra, like whether you read the numbers diagonally or in a spiral pattern or by skipping specific intervals, the underlying numbers would translate to entirely different phonetic sounds.
Wow.
By shifting the cipher path, he was actually able to encode 18 different scripts and over 700 distinct languages within the exact same numerical matrices.
Over 700 languages hidden inside numbers. I mean, think about your daily routine right now. Every time you purchase something online or log into your banking app, your personal data is protected by modern AES encryption, the advanced encryption standard. That entire digital security apparatus relies heavily on block ciphers, which are essentially modern digitized matrices that scramble data based on algorithmic keys. Modern cryptographers look at Kumudendu Muni's 9th century grids, and they instantly recognize the deep structural precursor to the exact mathematical combinatorics protecting the global digital economy today.
It's true. I mean, most famous ciphers from the ancient world, like the Caesar cipher used by Roman generals, were mathematically quite linear. They're relatively simple to break. What Kumudendu Muni built was exponentially more complex because it operated in multiple dimensions simultaneously.
Right.
The cipher is so dense and mathematically demanding that, out of the 26 chapters contained in the Sirabhuvalaya, modern scholars have only successfully decoded 3.
Only 3. Over 1,000 years later, and humanity still hasn't cracked the whole code. It really leaves you wondering what massive scientific or philosophical insights are currently sitting there in plain sight, completely unreadable to us.
Yeah, it's a tantalizing thought.
But as Kumudendu Muni was exploring the deeply hidden, sort of microscopic patterns of numbers, the final scholar in our deep dive was looking in the exact opposite direction. He was tackling the macroscopic limits of human comprehension.
We move to the 12th century now, where 500 years of compounding intellectual momentum in Karnataka reaches its absolute apex with the mathematician and astronomer Bhaskara II.
Okay.
He was born in 1114 CE in the city of Bijapur, and he eventually rose to become the head of the Jain Observatory, which was the premier astronomical research center of ancient India. And in 1150 CE, he finalized his masterpiece, the Siddhanta Shiromani.
The contents of the single text fundamentally rewrite the timeline of global mathematics.
Without a doubt. Within its pages, Bhaskara II outlines the foundational concepts of differential calculus.
Yes.
We were talking about the concept of instantaneous velocity, the core principles of a derivative, and mathematical functions approaching limits. He articulated these concepts a full 500 years before Isaac Newton and Gottfried Leibniz formalized calculus in Europe.
And to understand why instantaneous velocity is such a massive hurdle to clear, just imagine tracking an arrow flying through the air.
Okay.
You can easily calculate its average speed over the whole flight, right?
Hmm.
But if you freeze time and try to calculate the arrow's speed at one exact, infinitely tiny fraction of a millisecond, standard algebra completely breaks down.
Right, you need calculus to measure continuous change at a frozen instant.
Exactly. But the breakthrough from Bhaskara II that I find genuinely staggering is his conceptualization of infinity.
Oh, yes. He became the first mathematician to explicitly state and prove that dividing a finite number by zero produces an infinite quantity.
Yeah.
He was mathematically anticipating the groundbreaking work of 19th century European mathematicians like George Cantor.
Okay, I want to challenge the mechanics of this for a second, because if you pull out your smartphone right now and you type 5 divided by 0 into the calculator app, the screen just flashes error.
Right.
The computer chip literally gives up. So how did a 12th century human mind conceptually leap past a system failure to realize the answer is infinity?
Well, it relies entirely on understanding the concept of a limit. Let's walk through the mechanism.
Okay.
Imagine dividing a fixed number, say 10, by a smaller and smaller denominator. 10 divided by 2 gives you 5.
Sure.
10 divided by 1 gives you 10. If you divide 10 by a tiny fraction, like 0.001, the answer shoots up to 10,000.
Right, it gets bigger.
Exactly. As the number you are dividing by shrinks closer and closer to absolute zero, the result explodes exponentially. Bhaskara II observed this trajectory and realized that the limit of this function, the point where the denominator actually hits zero, cannot be measured as a finite quantity. The quotient expands forever.
Wow.
He conceptually grasped the infinite limit centuries before the formal notation for limits even existed.
The sheer computing power of his brain is unbelievable. But, what ensures Bhaskara II's legacy isn't just the cold, abstract math, it's the deeply human, emotionally resonant story behind the most famous section of his masterpiece.
Yeah, the arithmetic section of his book, which is titled The Lilavati.
And the legend behind how that book got its name is incredibly poignant. Bhaskara II had a daughter named Lilavati. And according to the story, her astrological horoscope carried a devastating prediction. She was destined to never marry and would remain childless.
However, Bhaskara II was not just a father. He was the master astronomer of his era. He used his immense computational skills to calculate the precise, mathematically perfect alignment of the stars. He was basically looking for an auspicious micro-moment in time that could override the prophecy and allow her wedding to proceed successfully.
He literally constructs a highly calibrated water clock to track time down to the exact second, ensuring the wedding rituals happen at this perfect moment.
Right.
And as the story goes, his daughter, Lilavati, dressed in her bridal attire, leans over the vessel to marvel at the clock. And as she does, a single pearl detaches from her bridal nose ring and falls into the water clock.
Oh, no.
It perfectly plugs the mechanism, the water stops flowing, the clock stops measuring time, the auspicious moment passes by unmarked, and the wedding is completely ruined. The prophecy fulfills itself through a tragedy of pure precision.
It's heartbreaking. As a father, witnessing his daughter's heartbreak, realizing she would never have the family she expected, Bhaskara II sought to give her a different kind of immortality.
Yeah.
He wrote what would become the world's most advanced, yet remarkably playful and poetic mathematics textbook, and he named it after her.
He actually embedded her name into the problems themselves, directly addressing her as he explained complex arithmetic and geometry. It creates this profound emotional paradox. The most advanced mathematical text on the planet, dealing with the abstract expanses of the universe, was forged purely out of a father's love, trying to console a daughter over a ruined wedding.
It really completely strips away the sterile robotic veneer we so often apply to historical science. These scholars were not just isolated human calculators. They were deeply feeling individuals, embedded in the politics, the spiritual debates, and the raw emotions of their era.
Which brings us to a final provocative thought for you to carry away from this deep dive. When you sit in a classroom and learn algebra or calculus, the formulas often feel like they just fell out of the sky, entirely disconnected from humanity. But all human knowledge is tethered to physical places and specific moments in time.
Exactly.
The exact same royal courts that funded the breathtaking mountain-carving architecture at the Ellora Caves were simultaneously funding the minds that formalized the zero and anticipated calculus. And right now, somewhere in the archives, sits the Sirapuvalaya, 600,000 verses of numerical code locked in ancient matrices.
Just waiting.
Right. It makes you wonder what other world-changing secrets, what profound ancient sciences are still locked inside those undecoded grids, just waiting for someone with a fresh perspective to finally find the key.
The scholars of ancient Karnataka really laid the foundation, but 1,000 years later, we're still trying to catch up to their brilliance.
If you decide to travel to India, we have a recommendation. Five Senses Tours organizes tours across India, which are immersive cultural experiences. You can email contact@fivesensestours.com. Note 5 is written as a numeral and contact@fivesensestools.com. Or WhatsApp to +919 845 677 446.